Today I'm just going to tell you a little bit about what we've been working on so far, some of the things we've been working on. And I have no commercial relationships with anything that I'm done here. I work full time for the FDA. So in the past few years, the few things that we've been doing over at the Human Foods Program, one of the things we've been thinking about is looking at all the data that we have, how best can we deploy artificial intelligence and machine learning in areas where we can become most efficient. So the question is, how best do you deploy this in areas where you would need the most help, right? And where do we get the most bang for our buck? So here I'm giving you 3 examples of things that we've been working on, and some of them are already in production. So one is the Warp Intelligent Learning Agent that is initiated by the Office of Food Chemical Safety, Natural Supplements and Innovation. So this all comes from our new reorg, and so the acronyms are longer than what you'd be used to if you've ever followed us. Wiley is designed to do signal detection and post-market surveillance. Can you guys hear me if I do this? That works better? Okay, all right, thank you. Thank you very much. So, and sorry about that. The Food AI Decision Engine and the Outbreak Investigation Tool are tools that are developed by the Office of Surveillance Strategy and Risk Prioritization. So the Food AI Decision Engine is used to predict which lines of imports, so these are imports coming into the country, to actually test for potential violations. The Outbreak Investigation Tool allows the program to actually do outbreak investigation at an accelerated pace, so they can determine where the root cause analysis was. Today, I'm going to talk to you about Wiley, which is what my group has been working on for the past few years, and we've deployed some of this into production already. So we designed Wiley as a data product, which means that it actually receives input from you and it learns from the user. And we designed it with a flexible architecture so that we can expand its use. So the base architecture of Wiley is designed around what the Human Foods Program regulates and what it regulates, right? So what it regulates, how it regulates it. And it's designed to do signal detection and post-market surveillance, but also do knowledge discovery. So if you find a signal, can you dig deep down and find out where that signal came from? So the sections that we roll into production so far include the signal detection portion, post-market monitoring, knowledge discovery, and recently we've been working with our Office of Communications to do stakeholder sentiment evaluation, and I'll tell you a little bit about those. So Wiley's signal detection portion uses a variety of data sources. So it uses scientific literature, uses public comments, public postings, blogs, news articles, and internally curated data. So it brings all of that data together and it tries to detect signals from that. Now, a few years ago, we had a publication from some from the FDA, others from other academic institutions that looked at how many food safety incidents are reported to the agency. And they came up with an approximate value of about 2% of that is reported to the agency. So we don't get a lot of reports. So a lot of times we are behind the curve chasing after the signals. The question was, can we get ahead of the signals? Can we actually, because people are talking about these things online, right? Can we pull that data in and can we get ahead of the signals? So we built Wiley to pull all of this data in, and it runs this through a series of algorithms and it comes up with the signal. It says, okay, all right, this is what I think the signal is. And then it allows you to then kind of slice and dice the signal and say, okay, what are the products that are associated with the signal? What are the chemicals? What are the adverse events that are being reported? So what I'm showing you here is one of the dashboards that is rolled out that signal detection. Now, one of the questions you would ask, right? So you train this on a data set and you say, okay, we've trained it, we look at performance, it's performing really well, but what happens when you give it real world data that is never seen before, right? How does that perform? So one of the things that we do is we ask ourselves, it's a new signal. Did Wiley ever see it as we roll into production? Did we ever see it over time? So one of the newest one was polysorbate 80. So I'm sure most of you heard about this. It was in the Washington Post in March. It was a big to-do. So we asked the question, did Wiley see this? Right. So we run that through Wiley and we ask, did you see this? And so it brings up the signal for polysorbate and it actually shows it up here. And then on the left here, it shows you the products that is found over time associated with polysorbate, right? And it'll tell you, okay, in all these articles, there are some pathogens and there's some adverse events that are reported with it. in here, you get a chance to decide how you want to scale your signals. Right? And there are different ways you can slice this, right? You can look at this contaminants, you can look at food additives, you can look at this chemicals, you can look at drugs, right? Because Wiley sees drugs as chemicals. We don't do drugs, so usually we just exclude it, but there's a filter in there for just pulling drugs if ever CEDA wants to look at it. And down here, it shows you the snippets of the articles. And Wiley does something where it uses a priority score, right? So it says, okay, scaling this for relevance between 0 and 100%, how relevant is the signal? And it's something that we've trained it on, and it'll say, okay, this is like about a 90% relevant to you, you should take a look at it. But what we're doing here is trying to understand, okay, if you were to go back in time, did you see this before the March Washington Post signal? And we see that Wiley actually saw this back in January. That was when one of the first original articles came out. So it actually flagged this January 17th and said this was a signal. We're a couple of months ahead of the Washington Post. But you can also look back in time. I know you can see this very well, but hopefully if you look at the slides, you would look at it. But if you look back in time, you can ask, did you see this at other times, right? And Wiley sees polysorbate has been a signal multiple times, more than just the March. It was in 2024, it was in 2023. So it's seen it back in time. So here I'm showing you some of the peaks of the major incidents that occur with polysorbate. Right? So you see it happening in, I think this is 2023, this huge peak is in 2024, right? So back in time, it sees these signals. So once it's in production, the idea is we look at this on a weekly basis or we look at this on a daily basis. So we will see the signal before it becomes a major issue. You can dig deep into the signal. You can ask, okay, what are the articles that are coming with this particular signal, right? So here is the polysorbate. Sorry, press the wrong button. Back there. All right, so this is one of our knowledge discovery portals, and what you can do is you can search for polysorbate AD, and it will bring up the articles that is found, right? So you can see here the article actually comes from the January 17th article. If you click on it, what Wiley does, it shows you a script of that particular article. It creates a summary of it. If it's a long article, you can look at the summary. We can also look at the whole text. Then what it does with the text is where it identified those substances and the adverse events, it flags those, right? So they are color-coded so you can tell where it's actually extracting that information from. Then it also highlights the sections where it thinks, okay, these are sentences that I think are relevant to you. So take a look at this and decide whether this is important. One of the things I didn't show, and I was sitting there and I thought, oh, I should have actually added this to the slide. Up top here is actually an option for you to either agree or disagree with Wiley. You can say, oh yeah, no, this is my signal, and this is completely irrelevant. And then it takes that information in and it learns for the next cycle. So the next time it becomes better at it. One of the other things we've done is ingredient monitoring. What is in your food, right? So we've purchased a large data set of food label ingredients. And what Wiley does is he pulls all of that information in, cross-references that with our thesaurus, which means we have an in-house database that contains everything that we've approved to be in food. And then he asks the question, have I seen this before? And if I've seen this before, is it delisted or is it on our books? Right? Is it still on our books? And so it'll identify all of the chemicals and all the substances that it's finding. And if it doesn't find anything, it flags it as, okay, this is flagged for review. Take a look at this. Tell me if it's real or not. If you tell it's real, then it's accepted, it keeps it. Now, sometimes we don't have all the normal like foods that you eat, like rice, peppers, and stuff in our database, because some of it is focused more on food additives than on just the general foods that you eat. So sometimes we have to tell it, okay, this is a regular food, and you need to like include it in your knowledge base. So it will include it next time. But the other thing it does is it takes all the tox data we have, right? Even if the additive is approved, it says, okay, are there new tox data on this? And if there's new tox data on this, I'm going to run this based on some sort of potential risk prioritization for you to take a look at. So it takes the tox data, it takes how many foods is this particular substance in? It will ask the question, what type of foods is it in? And then it will ask, if it's in these foods, what is the sales of those foods related to another? So basically, do we sell more milk, presumably drink more milk than we eat rice, for example? And then it uses that to scale this in a level of importance and says, okay, you may have already approved this, but take a look at this again, because if there's new tox data on it that says this, if it's not being used right, there might be a problem you need to take a look at. Right? That allows us to now focus post-market and say, hey, let's take a look at this and if there's anything we have to worry about. The other thing it does is because it knows, it has a list of things we've delisted, things we've said cannot be in food anymore. If it sees those, it flags us up top. So it pushes up to the top thing and says, I don't care what the exposure is on this. It shouldn't be in food and you need to do something about it, right? And then we can coordinate with compliance and try to get something done on it. The other thing we started working on recently with our Office of Communications is, because we know we get fewer reports directly to us, the question is, people are always talking about what concerns them in food. Can we get that from social media? So we started pulling data from Reddit, Instagram. We are yet to work on Facebook. What this does, it brings in all the data of people talking about foods, right? And then it really tries to create topics for these. Okay, what are the topics that people are talking about and what are they discussing? That allows us to understand what you're worried about. I got 5 minutes. To know what you're worried about and how we should address it. But it also talks about, okay, if you're talking about this, what are the symptoms you're reporting, right? Are the health concerns that you're reporting? What type of foods? What type of foods? Oh, adverse reactions. So if you're having adverse reactions, what are they, right? But it also shows you, okay, what kind of food additives are we concerned about? It shows us the trends, shows us all the things that you may be concerned about. And then it gives you snippets of the text, right? So that tells us, it allows us to then cluster, are people having like foodborne illness that we don't know about? Are people concerned about food additives that we don't know about? If there are things that we've already approved in food, how do we address it? Is it a question of education? Is it a question of kind of posting more things about that particular thing online for people to learn more about that particular substance so they are not particularly worried about it? Because we may have already evaluated it. So in more recent times, what we started doing is can we become more advanced with some of our knowledge discovery, right? So one of the things we've done is Ask Wiley, which is one of our knowledge discovery engines. We've implemented generative AI into our tool. So far, the way we've implemented it is we've used it as a helper model, which means we use it to condition either data before our base models run, or we use it to refine the end game. So we've never actually used it to be our main source. But we started, okay, we can advance the knowledge discovery if we can implement this in a way where it's controlled. The other thing we are doing with our state partners is to build a model that allows them to predict where they're going to find violations in the testing samples to enable them to be more efficient in what they pick for testing. We've also been working with multiple program offices to build a model that actually predicts economic adulteration in food. So that cuts across multiple of our offices. So we can say, okay, we predict this is going to be adulterated with something specific, and you may want to start testing these particular products. One of the things that we've asked about is, can we get ahead of a signal, say 2 years ahead? And the way we thought about this is, if we can take data from NIH and USDA on grants, what grants are you funding? And those grants, what are the abstracts? What are the preliminary studies from those grants? We can get a heads up on things that are coming down the line, maybe 2 years down the line. Right? We are researching this and we think this is important. We are researching emulsifiers and we think it's important, or sweetness and we think it's important. That allows us also to start our own studies on it, right? So we can be ahead of the curve when this happens. This is an example of Ask Wiley. Ask Wiley is, we are building this in multiple flavors. One of it is Ask Wiley Admin. So this answers administrative questions. So this is for our admin staff and for acquisitions, right? So they can ask a simple question like, what is a bona fide needs rule? I have no idea what that is. I'm a scientist. But if I put that in, it tells me exactly what that is. And that helps our admin staff, rather than go through a lot of documents to actually understand that, they can easily ask the question and then get an answer to it. What we're also building is a Ask Wiley regulator. That's a different flavor of it. That knows the CFR for food, for the food regulation. So 170 to 199. And the idea is that our reviewers can then go in and ask questions specific for the status of a particular substance. But also that means Wiley then knows the status of substances as it picks new signals. So it will know what is the regulatory status for this. And if it can't find it, it can easily flag it for us to review. This last one just shows you what we are working on with the laboratories. So the idea is that they have all these different analytes. We can pick it, we can tell them what the explanatory variables are, what are the biggest predictors of what is going to be violative, and what is where you're going to find your pesticides. Right? So if we can tell them that, they can then target their testing and say, okay, we picked samples from these areas because those are the factors that determine what is virality, right? And they can be more efficient in that process. Thank you very much. Oh yeah, I got that one.